Hey students, we are doing 2024 paper 2 of May-June variant 3. And now we are on question number 21. The previous questions are in previous videos. You can go through it. Lead iodide is formed as a precipitate in the reaction shown. This method is used to separate lead iodide from the mixture. It's really easy because it's a precipitation reaction, and in a precipitation reaction, we will take the two soluble salts. Here we have taken lead nitrate and sodium iodide. So we have two soluble salts and they are making one soluble and one insoluble. So you can see there's one insoluble salt forming, which is solid, and the one soluble salt forming sodium nitrate. So in the test tube, after the reaction, we will get a solution, which is sodium nitrate. And then we get some tiny precipitates of lead iodide. How can we remove them from the mixture? How can we remove the potassium iodide from the mixture? Really simple. If we have any insoluble solid in a liquid mixture, then we will filter it out. We'll separate it by doing filtration. This statement explains why sulfur has similar chemical properties to selenium. Sulfur and selenium both are present in the same group. And if they're present in the same group, sulfur and selenium, they both are present in group 6 of the periodic table. If they both are present in group 6, that means both of them have same number of electrons in their outer shell. And the chemical properties depend upon the number of electrons in the outer shell. So this one is A. Question 23. Atoms of sodium, rubidium, and element Q each have one outer shell electrons. It means that all three elements are present in group 1. They have one electron in the outer shell. Some properties of these elements are shown. Okay, so you can see here we have sodium, rubidium, and then element Q, whose identity we have to find. It can't be hydrogen, obviously. So the melting point is, as you can see, the melting point is decreasing, 98, 39, and 28. So element Q has lowest melting point. And the boiling point is also lower than the rest of the two. And the density is more. And as in group 1, we know that its melting and boiling point increases as we go down. Melting and boiling point decreases as we go down because they become softer and softer as we go down. The size becomes big. Atomic size increases and they become softer. The electrons become far from each other, so it will be easier to melt and boil them. So that is why the melting point decreases as we go down. And because the size is increasing, so the density increases. Density is the measure of how heavy they are. So the number of particles, number of shells are increasing, and also they are taking up more space. So the density is increasing. Now, what is this element? It can't be lithium because lithium is present above sodium. So lithium must be having more melting point, more boiling point, and less density than sodium. So can't be lithium. It can't be potassium because potassium is present between sodium and rubidium. So the answer is cesium because cesium is present after rubidium. So cesium is correct. Question number 24. Which statement about elements in group 8 of the periodic table is correct? Now, as we know, the group 8 is of noble gases and their outermost electrons are complete. They don't react at all. They have full outer shell of electrons. They all react with group 1? No, they don't react. They all are diatomic? No, they are monoatomic. All the gases are monoatomic. They are all liquids at room temperature and pressure. No, they are all gases. The answer is A. They all have full outer shell electrons. This makes them unreactive and noble. Question number 25. Electrical conductivity of magnesium is tested. Magnesium is then added to dilute sulfuric acid. A gas W is produced. Which row describes the electrical conductivity of magnesium and identifies W? So magnesium, as magnesium is a metal, so its electrical conductivity would be good because all the metals have delocalized electrons, which makes them a good conductor. And when magnesium is reacted with dilute sulfuric acid, H2SO4, magnesium plus H2SO4, magnesium displaces hydrogen, take its place, and forms magnesium sulfate, MgSO4, and this displaced hydrogen will form hydrogen gas. So this W is actually hydrogen gas. So the answer is A. Question 26. Aluminium metal is extracted from its purified ore by electrolysis. Which statement about the electrolyte in this process is correct? Now, what electrolyte we will use? Electrolyte is the ionic compound or any substance, can be any substance which conducts electricity. Anything which conducts electricity. So here, in the extraction of aluminium, we get aluminium oxide as electrolyte. Will melt it, but because its melting point is very high, we need cryolite to lower down its melting point and make it soluble, make it in the liquid form. So the electrolyte is purified bauxite only? No, the electrolyte is purified bauxite dissolved in molten cryolite. Yes, because aluminium oxide, bauxite, they're saying about aluminium oxide. Bauxite is ore of aluminium, which contains aluminium oxide. And plus, we're adding cryolite so that aluminium oxide can be mixed with each other and its melting point will be lower down. So basically, both of these things are used as electrolyte in this process. So the answer is B. Question 27. The part of the reactivity series is shown. Which metals are represented by X and Y? This is a part of the reactivity series. Potassium is very highly reactive. Then we have some X, and then we have calcium, which is present in group 2. It also has high reactivity, but lesser than potassium and element X. So element X, it will be sodium. It can't be copper because copper is very less reactive. It is present at the end of the reactivity series. So no copper, it is sodium. Then calcium, after calcium, aluminium is present in group number 3. Calcium is in group number 2, aluminium is group number 3. So Y, it must be magnesium, not silver, because silver is also least reactive element. So the answer B is correct. X is sodium and Y is magnesium. Some substances found in water extracted from a river are listed. Plastics, nitrates, we get nitrates from fertilizers. And then we have oxygen, which is absorbed into the river from air. Which substances are harmful to aquatic life? What substances are harmful? Obviously, very clear, the plastics are harmful and the nitrates, because when they are accumulated on the surface of the ocean, they block the entry of sunlight and oxygen. So in the ocean, if there is a layer of plastics, they accumulate at one place, or if the fertilizers get washed off from the field and come to the river, they block the entry, they form a barrier, and they block the entry of oxygen and sunlight. So oxygen and sunlight, it will not be able to enter into the water, to get dissolved into the water, and the marine aquatic life will get affected. So 1 and 2. Question number 29. Car engines which use gasoline as a fuel produces oxides of nitrogen. Oxides of nitrogen are removed from the exhaust gases. Which statements about the formation or removal of oxides of nitrogen are correct? Now, as for the car exhausts and the catalytic converters which are present in it, the nitrogen oxides, the oxide of nitrogen is formed into the car engine because the nitrogen and oxygen which are present in the air, they react with each other at very high temperature. In engine, there is a very high temperature, so nitrogen combines with oxygen to form nitrogen oxides. These nitrogen oxides are very, very harmful. So in catalytic converter, these nitrogen oxides is converted into nitrogen gas, which is less harmful. And how they will convert these nitrogen oxides? The conversion happens when nitrogen oxides react with carbon monoxide and gets reduced into nitrogen. And this carbon monoxide will form carbon dioxide. So nitrogen oxide undergoes reduction to form nitrogen gas. This happens in the catalytic converter. So which statement is correct about the formation and removal of oxides of nitrogen? Gasoline reacts with nitrogen in the air to produce oxides of nitrogen. Gasoline reacts with nitrogen in the air? No. Gasoline does not react with nitrogen. Nitrogen reacts with air to form oxides of nitrogen. Gasoline contains nitrogen. This is also not correct because nitrogen comes from the air, not from the gasoline, not from the petrol, not from the hydrocarbon. Nitrogen oxygen react at high temperature to produce oxides of nitrogen. This is correct. Nitrogen monoxide reacts with carbon monoxide in a catalytic converter. This is also correct. So the answer is 3 and 4. Which structures represent a pair of structural isomers? Now, if we see the structural isomers they are the compounds which have the same molecular formula but different structural and displayed formula. So they have same molecular formula but different structured formula. So we have to see in each of them that which two have same molecular formula. How will we do it? We'll count the number of hydrogen atoms in each of them. So let's count. In number 1, 1, 2, 3, 4, 5, 6. We have 6 carbon. As for the hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15. We have 15 hydrogens. 14, sorry. We have 14 hydrogens. Number 2, 1, 2, 3, 4, 5, 6. And 6, we have 2 CH3, so total 7. Okay, CH3, last CH3 is twice times. So we'll count it 2. And for hydrogen also, we'll count it not 3, 6 for the last one. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. For this one, 1, 2, 3, 4, 5, 6. 6 carbon. For the hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 hydrogens. 1 and 3. But let's count for number 4 also. For the carbon, 1, 2, 3, 4, 5, 6, 7. 7 carbons. And hydrogen are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 hydrogens. Wait, 2 and 4 can also be correct. But let's revise it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Here we have 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is also correct. But they are saying for the their structure formula or displayed formula would have to be different. For number 2 and number 4, their structural formula, they are exactly the same. And for 1 and 3, the structural formula is different. For 2 and 4, both of them are branched. Here we have this one and this one, both of them are branched. There is a branch of methyl in 2 and 4. They're branched. But 1 and 3, 1 is just normal, it's straight chain. It's straight chain. And the third one has a branch of CH3. It is branched, which makes number 1 and 3 structural isomers of each other. The 1 and 3 are correct. The rest of the questions will do in my next video. Stay tuned.